All right, chapter 3 is developing a program. And in essence, what we're doing is really problem solving. So I put that as a subtitle because I really think that's what we're trying to establish here in chapter 3. And in reality, every single day we are problem solving and we don't think a whole lot about it. For example, if you have a to-do list, you go through your to-do list and you figure out a plan of action. What are you going to do first? What's more important? I have to do my homework. It's due at midnight, so I have to make sure that I get that done after I finish work and feed the kids, or whatever your situation is, but you're planning out a plan of attack. Same thing, maybe making dinner. I'm going to make dinner, so I have to make sure I go to the grocery list. I got to buy this and that. Or maybe your plan for McDonald's is you're driving, or you want to go to McDonald's. You're driving home and you say, I'm going to just have McDonald's tonight because it's easier. But even then, you have to create some kind of problem solving in order to get from where you are. What streets am I going to drive? Oh, I don't want to go down that street because it's construction or whatever. So you're problem solving on a daily basis. But unfortunately, when we get into programming class and we see something like this, we panic. It's a word problem and we tend to, oh no, and break down and cry. Well, hopefully you're not going to cry. But the idea here is that this chapter is giving you some little bit more strategic ways of solving or tackling programming problems. And it's a great foundation to build on because it's something that you'll be doing not only in this class, but subsequent classes if you go on and take Java and C# and any programming you do is simply problem solving. And so I want to help you with this chapter, kind of break it down and organize it in a way that I think will be helpful for your future success in programming. So I'll give you a second to read over this problem, get over the panic attack, because that's always what I feel when I first look at a problem. And then we'll figure out from there what we need to do. So I'll be quiet for a minute, let you read. Oh, there we go. Okay. So now we kind of have an idea. We've been asked to create a program which can estimate the cost of gas for an employee to drive from one location to another. Presumably we're using company cars for the travel, and all the cars get 17 miles per gallon. And the program should print out the total mileage and the total price of gas needed for the trip. Okay, well that's a lot, and I'm panicking. So how can we break this down or what do we do when we break down code, and what's the process? So let's just look at the overall, and we'll break this down here in a minute. The first thing to do when we're programming is we want to analyze the problem. We're going to analyze it by looking at the output, input, and processing. And I'm just going to breeze through this for a moment because we're going to go back and tackle each of these. So once we've kind of analyzed what it is we're trying to tackle, then we're going to work on creating a design for it. And we saw pseudocoding last chapter. One of the last videos, the last portion of this chapter is going to be about flowcharting, so we'll see about that. So we have some design tools that help us create designs. Then we actually go in and program the code and in the syntax of the language that we are choosing to code in, whether it be Python, whether it be C# or Java. And then we test our code. And that's the last thing that we'll do, is make sure that the code's doing what it's supposed to. And very oftentimes, this isn't the end of it. We might go back to the beginning and we determine that there's some issues in our testing, and so this might be a cyclical process. So we will go back and start again, analyze what we've done, figure out what we need to change, recode it, test it, and it can continue on and on. So, but these are the general guidelines, and we'll look at each of these in detail. Analyze, design, code, and test. So the first thing I want to start on is analyze. And that's what we're going to look at in this video. So again, looking at that same problem, let's analyze it. And truthfully, the easiest way to analyze this, instead of reading each line in order, let's look at it from a different perspective. We talked about in the last chapter that everything we do in programming basically has input, processing, and output. That's really all we're doing when we're writing a program. So when we're analyzing, when we're taking that first step of breaking this word problem apart to figure out how we're going to solve it or how we're going to program it or create what we're being asked to create, the easiest thing is to look at the output first. What is it that we're supposed to get from the program? What's the end result? What is the program supposed to do in the end? And if you read this and kind of gloss over all of the verbiage, we can see at the end that ultimately what we're trying to do is print out the total mileage. Your program should print out the total mileage and the total price of gas needed for the trip. So that's our ultimate goal. That's our output. So how far did the employee travel, and how much does that price of gas cost the company? That's our ultimate output. Once we have that in our head, this is our goal. We can put this up here in little bullets so that we keep that in the back of our mind. The next thing to do is figure out, all right, now that we know what we're supposed to get, what do I need in order to make that possible? What do I need in order to get the total mileage? Well, in order to get the total mileage, I need to know how far the employee traveled, right? So that's one of my inputs. So I need to accommodate for the distance the employee will travel, so that way I can calculate the mileage. And what's the other factor I need? I need to know how much gas costs, right? So the current price of gas. And so now I know what I need to output. I know what I need to get that output. And then we can kind of fill in the blanks from there. And based on whatever input we have, we need to process that information to get our output. And we call that algorithms. Algorithms is a very fancy word to help us sound really cool as programmers. And all that means is just creating calculations. What kind of calculations do we need? What are the algorithms? What are our math formulas? What are our problems? What are our step-by-step things that we need to do with our input to create our output? And sometimes when you're looking at the processing, you might decide you need some more input. That's fine. This is the place to kind of decide that. So let's think about what we need in order to process our input to get the output. So we know that we need to know the total gallons needed, and that's a calculation. We need to know how many gallons that car is going to use to drive from point A to point B. And so to get that, that's just a simple math formula. You take the total mileage and you divide it by 17 miles per gallon. We know that car gets 17 miles per gallon. So if for each gallon it can go 17 miles, then in order to know how many gallons we're using, it's just total mileage divided by 17. Okay? So now we know how many gallons, or we can calculate, or we've created an algorithm to determine how many gallons are needed for this trip. And then to figure out how much the total gas price is, we take the gallons needed from our calculation above and we multiply it by the price of gas per gallon, which is another input. So here we're creating two algorithms that are taking our input, processing it to get our output. And now we know we have all the data that we need because we can see our calculations are now sufficient to produce the output that's required from our program. So stage one, analyzing. The easiest way to attack a problem is to first freak out, and then after you're done with the freak out, back up a little bit and break it into smaller bite-sized pieces. And the way to do that, the easiest way I think to do that, and the way the book's laying this out for us, is first figure out, all right, what do we need to output? What is it that it's wanting from us? What do we need to get from our user to get that output? And once we have that information, we can do our processing. So in the next video, we'll do the next stage, which is design.